What is open-loop control in industrial PID tuning? Imagine trying to steer a boat without looking at the water or the waves. You make a move, see how the boat reacts, and then adjust accordingly. That's similar to what open-loop control is in industrial PID tuning. It's a way to set up control systems without constantly checking the process variable during the initial setup. In this method, the controller is put into manual mode, meaning it doesn't automatically adjust based on the process. Instead, you manually change the controller's output by a known amount, like turning a valve or adjusting a heater. Then, you watch how the process responds over time. For example, if you increase the heat, how much does the temperature change? How long does it take to reach a new level? These responses are carefully recorded. The main idea is to gather data about how the process reacts to a known change. From this, you can estimate key characteristics like process gain, which shows how much the output changes relative to the input. You also measure dead time, which is the delay before the process starts to respond, and the time constant, which indicates how quickly the process reacts. These numbers are then used in specific formulas or rules, like the Ziegler-Nichols open-loop method, to calculate the initial settings for the proportional, integral, and derivative gains of the PID controller. Open-loop tuning is especially helpful when setting up new control loops or after making big changes to the process. It doesn't require the system to be in automatic mode during testing, so it's safer and easier to perform in many industrial settings. This approach gives a solid starting point for PID tuning, which can then be refined further for better control. In the world of smart manufacturing and advanced robotics, open-loop control helps speed up the process of getting control systems ready. It allows engineers to quickly gather data and set initial parameters for controlling variables like temperature, pressure, or flow. This method is a practical way to kick off the tuning process before moving to more precise, closed-loop adjustments. While it provides a good foundation, fine-tuning is often needed afterward to ensure the system runs smoothly and stays stable during operation.